I'm just testing my voice. Hi, Ashutosh.
Hi
Hello, Shiv.
Ashutosh.
Hey, everyone.
Are we audible to you?
Yeah, perfectly fine.
Yeah, we're just testing the audio. Just give us 5 minutes. I'm so sorry for the delay.
That's okay.
Okay. Okay, so Ashutosh, do you have a PPT that you'd like to share? I mean, you can start the screen sharing now if you're using your laptop, or you can send the PPT to us. Uh, will you be sharing your screen?
Yeah, I'll be sharing my screen.
Okay, so Devij, as soon as he shares the screen, we can start with the live stream. Okay, we can start with the meeting, the session.
Yeah.
Okay, so yeah, welcome to VIT blockchain community, Ashutosh.
Happy to be here.
Okay, I'm so sorry. I had some trouble with my mic. So, welcome to VIT blockchain community, Ashutosh. It's a pleasure to have you here. And Divish will be your host for today, and he'll be taking on with the session with you from here. Thank you so
Awesome.
much.
Hi Ashutosh. So if you could please share your screen and then I'll begin with the introduction and we'll begin with the meet.
Okay, sure thing. I'll share this window. Can you see my screen?
Yeah,
Can you see the presentation now?
yeah.
Perfect.
So I'll just begin with the introduction and we'll just proceed then.
Okay. Do you want me to turn on the camera? Okay.
Yeah, it would be for the initial introduction part, yes. After that, you whatever you feel comfortable with.
Okay. I think it's all right.
Okay. So hi everyone. Today we have with us Mr. Ashutosh Tripathi, who is currently working as a developer relations engineer at Ava Labs. He completed his engineering from NIT Jalandhar in instrumentation and control engineering. Previously, he worked as a senior technical writer at Polygon Labs, managing Polygon Wiki. Prior to that, he built a few dApps on Solana and Near Protocol and won the Encode 22 challenge and worked as a technical writer and DevRel at Push Protocol. So he will take over from now, and today he will teach us how to build decentralized application. And I'm just going to give the mic to Mr. Ashutosh, and he's going to carry forward the meeting.
Okay. Hello, everyone. I guess I'm audible, but just let me know by raising a hand if I'm not. And if you guys can see my screen, that's all good. So, hello everyone. I'm Ashutosh, and I work as a developer relations engineer at Ava Labs. Ava Labs is the company behind Avalanche blockchain. So we help make the Avalanche blockchain successful, like all the BD efforts and all the developer etc. things, kind of stuff that we manage. Now, in today's workshop, we are going to learn about what exactly are decentralized applications, how you can build them on Avalanche, what is Avalanche, what is our like subnets architecture, like what is our overall thesis on blockchain ecosystems, and then you'll learn about how you can build your own blockchains as well as build your own, let's say, example applications on chain on Avalanche. We'll also deploy a simple ERC20 contract. You don't need to have the laptop handy, but if you have, it's good. All you will need is just your GitHub profile logged in. That's it, and I'll share the links with you. So let's move to the first slide. I'm not a very big fan of presentations and all this stuff, but if anybody of you wants to read it from here, you can. It's meant to be like summarize the whole thing for you, but you can also listen. So I'll try to put it down very briefly. So Avalanche is essentially an L0 L1 ecosystem. When I say L0, I mean a layer zero ecosystem where you can build blockchains on top of it. And when I say L1 ecosystem, then I refer, then in that case, I'm primarily referring to the C chain, which is the contract chain where all the decentralized applications are currently built on Avalanche. So it's a performant, modular, and VM agnostic platform which can help you either launch your blockchain or launch your decentralized applications. Avalanche is not a single blockchain network. It's not a side chain to Ethereum. It's not a layer two blockchain, and it's not just another EVM compatible blockchain network. It's actually a network of fast layer one blockchains. And contract chain, which is the C chain, is one of them, where most of the decentralized applications are today deployed. Now, some of the distinctive features of Avalanche ecosystem are like we have more than 1,700 validators. You can check them out. It's publicly available data. It's an L0 platform so that you can build either your own blockchain network or you can build the apps. Why I'm focusing so much on building your own blockchain, I'll get into that later on in the upcoming slides. So we do have the groundbreaking Snowman consensus protocol. We developed this whole thing in-house by our co-founders. We'll talk about that as well in the next slide, upcoming slide itself. And interoperability, which is like available at the networking layer for all the chains that are launched using Avalanche. So we'll talk about the need of interoperability and why it's important, how you can utilize it on Avalanche as well. And then the VM development SDK. I don't think we are going to discuss more about Hyper SDK today, but if we do host a workshop in the upcoming months, then definitely we'll discuss in more detail about Hyper SDK. So first things first, what did Avalanche do in this whole blockchain industry? I mean, you might have heard about Bitcoin, you might have heard about Ethereum, Solana, Polygon, and all the other stuff. And all of those blockchain communities which are active in India, you might have heard about them because of their hackathons and bounty programs. But what is like unique about Avalanche? So I started working here at Ava Labs last year, and I think before joining Ava Labs, I knew very little about Avalanche ecosystem, what it is, Snowman consensus. These are things that I never knew about. So when I joined, I first looked that okay, what sets us like what is actually unique to our ecosystem, what sets us apart from other, let's say, EVM compatible chains or other, let's say, monolithic chains like Solana. So first thing was that we have a very unique Snowman consensus mechanism, which is the third generation of improvement in the whole history of consensus mechanisms, which are built in distributed computing systems. So there were essentially three generations. First one being the classical one, second being the Nakamoto one, third being the Snowman. So classical consensus was used by Facebook's Libra BFT and Cosmos. Even Cosmos chains, they used, you can say, modified version of classical consensus mechanisms. What happens in classical is that you send a message to all the nodes. For example, let's say you have a distributed system of 100 nodes, right? You have a 100 validator blockchain network, and you want to settle a transaction in such a network. So as a user, I will send my transaction to one of the nodes out of these 100 to the RPC or using the RPC URL. Once my transaction gets sent, that okay, this is the account balance changes that I want to do in this transaction. First node will compute that okay, this needs to be the final state of the chain after this transaction is settled, and then it sends that state transition to all the nodes that are available in the ecosystem. Let's say we have 100, so it will send 100 messages, 99 messages to be precise, to all the nodes, all the 99 nodes in the ecosystem, in the validators set. And once all of them also compute that okay, the state transition data submitted by validator one is correct, then only it will get settled as a block in the whole blockchain network. Now the problem with that is that if I'm assuming that most of you are computer science students here, but just for the sake of brief history, there is something called time complexity and network latency. So as soon as you add more than 100 validators to the network latency takes a lot of hit because you have to exchange O of n square messages. So as soon as, let's say, you have 200 validators in the ecosystem, you'll be sending 200 square messages per transaction, per settlement. So this makes the whole blockchain ecosystem slow, and classical consensus mechanism cannot settle cannot be used for blockchains where validator sets are, let's say, more than 200 or 300. This is the limitation. And even today, if you want to, let's say, test it out, if I'm saying correctly or not, you can go and test out all of the Cosmos blockchains that are built using Cosmos SDK, and you will see that they have less than 100 validators, all of them. Even the Polygon POS chain is a modified version of Cosmos SDK. They use Cosmos at some level, and I think in Heimdall or whatever, and they also have just 100 validators. So the problem with classical consensus is that you cannot have a heavily decentralized ecosystem. When I say decentralized, I mean that okay, there should be at least such a level of fault. You can say fault tolerance, so that if let's say 50% or 60% of the system goes down, there is still some hope that okay, the whole network will survive. So in 2008, Satoshi Nakamoto came up with the Nakamoto consensus, which is widely used in Bitcoin itself today. As you can see, Bitcoin has like a lot of validators, more than 100K validators today. But the problem with Bitcoin is that all the transactions, because of the network latency, they settle in like almost 60 minutes. So the time to finality to settle a transaction when you send it on Bitcoin chain is almost 60 minutes. When I say time to finality, what I mean is I send, let's say, one Bitcoin to you, and after a time of 60 minutes, it will be completely settled on chain. There might be some sort of, you can say, what do we call it? Optimistic finality that can be shown on wallet interfaces or something like that. But overall, the time to settle transactions completely on chain on Bitcoin will be 60 minutes. Similar thing goes for Ethereum as well. Ethereum settles transaction in 15 to 20 minutes. All the layer twos that are built on top of Ethereum, they settle transactions in 15 minutes plus the block finality time of layer twos. So you can assume it's like almost 15 to 20 minutes. Now we realize that okay, this is not going to be the way to scale blockchains, because as a financial institution, let's say you are a financial institution like JP Morgan or Citibank, would you like that okay, your transactions are settled in like there is some sort of you can say probability that your transaction might get reversed in the next 50 minutes? Would you like that? No, you won't. If you want to use it for let's say daily payments, for example, I'm sending money to my Uber driver, will there if there is any chance that the transaction gets reversed in the next 15 minutes, is it a good method of payments? No, it's not. So this is why we developed Snowman consensus mechanism. It was developed by Emin Gunserer, Kevin Siknicki, and Tedian. They were like professors at Cornell and PhD research students. So they developed Snowman on the, let's say, concept. From what I understand, it uses the concept of I would try to put it as layman as possible, the wisdom of crowd. So if you want to, let's say, quickly find out in a bunch of 100 people who likes red color or who likes yellow color, and you just want to know that, okay, what is the majority of people loving which color? So you can just ask that, okay, all of the people, if you create a group of, let's say, five individuals, and you will ask each of your neighbor which is the color they prefer, red or yellow. And on the basis of the majority of your neighbors, they will change that, okay, this is the preferred color among the majority of population. So if I ask, let's say, five people surrounding me, and four of them reply that, okay, I like red more, then I will assume that red is going to be the preferred color. And then I will go again to another set of people and ask them the same question. Now, in this method, the settlement of transactions is much faster, which is why we utilize this random subsampling of validator sets to finalize transactions. Now, you will be wondering what is unique here. So the transaction per second, obviously, it's more than Ethereum. It's almost like 1,000 TPS, which is what we touched last year in during the ordinance rush on Avalanche. But at the same time, we settle transactions in less than 2 seconds, with the block finality being 2 seconds only. So each transaction, as soon as it's settled in a block on Avalanche C chain or any of the Avalanche L1 blockchains, it is settled in block. It is like finalized on chain, and there is nothing you can do to reverse. Now, as soon as I understood that, okay, this is a like a unique consensus mechanism, it can make things actually faster. There is an actual improvement that is happening. Now I started comparing it with, let's say, monolithic chains like Solana. So Solana also settles transaction in almost 2 seconds. But the problem with Solana is that being a monolithic chain, they do have very high hardware requirements, but we don't have high hardware requirements for validators. You can create a validator just from your MacBook Pro M1 or like an 8 GB machine. So you can run a validator just from 8 GB RAM. That is like one of the unique things that is unique only to Avalanche. And now this consensus layer, this enables, firstly, it enables us to build a C chain which utilizes a Snowman consensus. But at the same time, we also provide you the consensus mechanism as a part of our tech stack, of the L0 tech stack, layer 0 tech stack, you can call it whatever, so that you can build your blockchain on top of the Avalanche consensus mechanism. You can use it as your consensus layer. So any L1 subnet, whenever I say a subnet, just assume that I'm talking about an Avalanche L1. Please don't think anything like subset or whatever. We are going to change the nomenclature very soon. But for now, just bear with me. So whenever I say a subnet, assume that okay, it's a completely independent blockchain network built using Avalanche tech stack in its ecosystem. So what your L1 subnet has from day one, the sub-second transaction finality, thanks to its Snowman consensus. Your L1 blockchain will settle transactions under 2 seconds. It is highly scalable. We have tested that okay, it can support 4,500 transactions per second. So if you are a person who is interested in Golang or want to experiment with virtual machines or have interest in like understanding EVM and try to replicate something into a better model, you can launch your own virtual machine on an L1 blockchain in Avalanche. Then independent tokenomics, so you don't have to rely on Ethereum, and you can launch your own token. And then subset of Avalanche validators. This is the most misleading line, but we are going to change that once the upgrade goes live. I'll talk about that later on. So uh, this was the first thing that we did, that okay, we need to make sure that transactions are settled fast and the throughput is high for every chain that is built using Avalanche consensus. We sorted it out. But now there was in 2018. So you see, we launched the mainnet on 2020. I think it was around May 2020 or August. So at that time only, the specific sector of blockchain developers, they were mostly focused on either Hyperledger, I guess, or they were mostly the EVM developers. So we needed to cater to those Ethereum developers so that they can port over their dApps to Avalanche seamlessly. Now, at the same time, we also know that okay, a single chain cannot support a lot of applications at the same time. Either you like make the throughput very high. In that case, there are a lot of other network considerations that you have to take into measure. For example, storage or whatever the validator set requirements, beefy machines you need to use. So we realized that okay, we need to abstract all three major functionalities that are essentially enshrined into monolithic chains like Ethereum. So on Ethereum, you can see that okay, the event layer is also on one chain, the execution is also on one chain, registration of validators is also happening on the same chain, and your dApps are also launched on the same chain. In our case, we have three chains. The first one being exchange chain or the X chain. X chain is meant for like creating native assets. You're not going to use it, so you can completely ignore it. Sorry for like taking you to exchange. But these are the two chains that you're going to probably use. Mostly this one, but you will also use P-chain while we set up our own blockchain networks. So P-chain is essentially used for setting up your validators. And whenever you are, let's say, creating a subnet and you are trying to register your uh, validators for your blockchain network, then you are going to register it on the P chain. And then C chain, as it's inevitable, the name is contract chain. So this is mostly like meant for deploying your smart contracts. Most of the Avalanche ecosystem applications, they are deployed on C chain today. We'll talk about them in the next slide. So C chain is essentially a fork of the Ethereum virtual machine. And just by changing the RPC URL of your hard hat config file, you can deploy your exact same application from Ethereum or any other EVM compatible chain to Avalanche C chain. Very simple. You don't have to change anything. All of the like standard Ethereum developer toolings, they are supported on C chain, like Remix, Damas. We do have our own wallet as well, Core wallet. We support it, but like you're free to use whatever you want in your dApps. Now, what's so special on C chain? So there's higher throughput. First thing, there is lower fees. Second thing, third thing, least time to finalize transaction. So if you are building a DeFi application or a financial application for payments, something like that, then using Avalanche C-chain makes the most sense instead of like utilizing a layer 2 or settling transactions somewhere else. Now, this was the Snowman consensus and how we think about the multi-chain architecture. So as you can see, even from the primary network, we had three chains. So we are a big proponent of a multi-chain architecture. I will give you a very, let's say, brief understanding of why we support multi-chain architecture so much. Imagine that uh, Facebook, Google, and Microsoft, all of their social media platforms and all of the services that they run. So they're running currently today in siloed databases. But imagine if you wanted to merge all of them into a single database like all of their data, into a single database, what will happen in that case? First thing, it will be very tough to fetch the data because you will have to read more records than you were initially intended to, because obviously there is tons and tons of new data that you have to ignore. Second thing is that like there are going to be more issues for creating such a database. Now, how do you fix it? I mean, the solution that is currently being used by all these platforms is that they use their own blockchain, they use their own databases. Similar to that, you can also treat applications like D apps that are built on top of blockchains, like Avalanche or Ethereum, as independent apps. So, what happens if, let's say, a decentralized application gets more than, let's say, 100K users? Is it going to be uh, rational to launch it on Ethereum or even on Avalanche chain for that matter? For me, the answer is always no. Reason being that a single blockchain cannot support billions of users that we want to onboard. I'm not sure when that onboarding is going to happen to Web3 and all this stuff. Like people talk about onboarding the masses into Web3 and all of these things. I don't know when is that going to happen, but that is surely going to happen in the future. When and when when the whole thing is happening in real time, do you think a single chain will be able to support all this, or do you need multiple chains? For me, the answer is multiple chains, very similar to how the answer today is multiple databases. So this is why we are a big proponent of like a multi-chain architecture, and make sure that all of these databases and all of these blockchains, they can share data between them. That is like the only requirement. Otherwise, if they are working as a sovereign independent chain, there is no issues. So what is a subnet? It's essentially Avalanche L1 blockchain that you can launch using our tech stack. Our tech stack, what it gives you, first thing, on the networking layer, you have Avalanche WAP messaging. So you can use WAP messaging to communicate with any other blockchain that is launched in the Avalanche ecosystem using the tech stack. Second thing, it gets you a completely independent layer on blockchain with up to 4,500 transactions per second and less than 2 second functionality. And with the upcoming ACP 77 upgrade, we are going to make sure that the requirements for setting up a subnet are much lower. So we might talk about like ACP 77 for some time, but I'll probably share you a link to the ACP itself. So yeah, when do you need a subnet? First thing, when you're building a very high performance application, then you definitely need your own blockchain. Whenever I say subnet, just assume that it's Avalanche L1. So if today I am a, let's say if I was the founder of Uniswap, and my Uniswap DEX users are suffering $35, $100 gas fees per swap on Ethereum blockchain, why am I still running this on Ethereum itself? The main the main need is like there is a notion that okay, you get security from Ethereum and obviously the access to liquidity, but these things can be, I think, if you build a good product, people will come. So even if like I was a chief of product of Uniswap, I would definitely recommend them to launch their own blockchain today, but it's okay. So if you're building a high performance decentralized application, for example, a Socialfy app, or let's say a simple game, you will see most of the games today, they are built on Avalanche L1s. This is like the very reason. Or when you want to customize the execution layer, for example, you want to use a different VM or something which is more powerful, like SVM or MoveVM, something which is more secure, then you need the option to customize your virtual machines. You get that option in Avalanche by default. So you can launch L1 blockchain with your virtual machine instead of just using EVM. And third, when you want a native gas token. So as you can see, like most of the L2 tokens, they are worthless today because they do not help in any way. Like people don't want to own those L2 tokens just because of governance and all this stuff, right? They want that, okay, if they're owning the token, they get some returns out of it, which they don't. For L1s, it does make sense because if you own the token and if you are validating the network, you are in some way contributing to its growth and you expect some return. So if you want a native gas token and don't want to pay your rent to Ethereum, you can launch a subnet with a native gas token. Now, what a subnet gives you? First thing, independence. Second thing, customizability. I think independence is pretty much clear till now because the traffic on subnet A is not going to impact the traffic or gas fee on subnet B, which in turn is not going to impact the gas fees on subnet C. This is like very simple put forward approach that, okay, if a database, if Facebook's database is having lots of requests, it's not going to impact the response time of Google's database. Pretty simple. This is the whole notion here. And customizability, So you can launch a DeFi application, you can launch multiple contracts, you can launch a DEX application. Whatever you want to launch, you can do it on your subnet. If you want to build it, if you want to like build it into a completely permissionless uh, EVM blockchain, you can do that as well, where any developer can come and deploy their smart contracts. Obviously, you will need a whole new level of effort in making the ecosystem succeed, but you can do that as well. Now, this is a very brief overview of what Ethereum blockchain looks like. So on the consensus layer, so Ethereum is a completely monolithic chain today. So on the consensus layer, they use Gasper. On the execution layer, they use EVM. And on smart contract layer, they use Solidity. So Solidity or Viper as well. But in Avalanche ecosystem, you can see that on the consensus layer, all of the chains are powered by Snowman consensus. On the execution layer, it can differ. You can use EVM from Ethereum. You can use SVM from Solana. You can use MoveVM from Aptos and Sui. And on the smart contracts there, you can have Solidity, Rust, Move, whatever language the VM supports. So subnets are cool. Is it tough to deploy an Avalanche subnet? Not at all. So it takes you 1 minute to launch your subnet using the Ava Cloud dashboard on the DevNet. It's obviously the testnet, so you can deploy subnets there. But in today's session, we are going to deploy a subnet using Starter Kit, which essentially uses CLI tool. So we have a CLI tool which you can utilize to deploy your own blockchain network. It will be completely your own independent network, and you can deploy it in under 2 minutes. We'll set it up later on in the hands-on exercise. Let's move on to warp messaging. So till now we understood that, okay, if you want a fast L1 blockchain, you need a good consensus mechanism. Snowman provides it. But you cannot do everything on a single chain. So you need multiple blockchains for that. Okay, good thing. We created subnets, aka Avalanche L1s for that purpose. Now, this essentially creates fragmentation in data as well as liquidity. Liquidity matters for DeFi applications. Data matters for applications like NFT protocol or community projects or social applications. So data matters for them. Now, how do you fetch data from a different blockchain and utilize it inside your smart contracts? There are different ways. Chainlink created a lot of toolings for that. But liquidity is still a question. Like, how do I get money from one chain to another, especially if it's in, let's say, Ethereum or let's say it's a C chain, and I want to bring the $1 billion of liquidity from C chain to some new subnet that I create using your tech stack. How do I do it? So we have warp messaging. Warp messaging is essentially a messaging layer. So it helps you send messages amongst all the L1 blockchains in the Avalanche ecosystem. So C chain. Now, the problem is that you can only send messages through it. You will ask, how can you actually like bridge assets? Like, how can you bring liquidity from C chain to subnet using warp messaging? So we have built Teleporter. Teleporter is essentially a wrapper around AWM, and it has some bridge contracts. So warp messaging helps invokes some, let's say, actions on smart contracts on the destination blockchains when you try to send a message using Teleporter. So if you guys want to like test out Teleporter or like some of the example applications, I'll definitely give it a try. I mean, definitely give it a try, and I can share you some of the examples that we built. All you have to do is just follow the guides, and you will see how you can create a token on C chain or any other blockchain for that matter, and bridge it just by using messaging services in some, which is essentially a warp messaging. So that is warp messaging for you. And HyperSDK, it's a customized VM building tool. Like, EVM is not the most performant virtual machine today. So if you want to build a new virtual machine and deploy it on a L1 blockchain today, then HyperSDK can definitely help you in that. Now, this is very quick QR links to Avalanche Academy, Telegram, and Discord. So I know that time is not too much for us to like for you to assimilate all this information. So if you want to learn more about Avalanche fundamentals course, then we have the Academy, which we recently did the UI upload for. So if you want to learn about Avalanche and our multi-chain architecture thesis theory part, then you should go to Avalanche fundamental course. This is the link, academy.avax.network. You can get it, or I can share it with you guys from Shagun or Divij. And if you want to learn about the multi-chain architecture and want to launch your own blockchain as well, you should take this course. Like, it's a very quick 1 hour course. You can just follow the guides step by step and understand along the way. But if you want to, let's say, create a bridge and try to set up some teleporter bridges, you can take up this course. If you want to learn more about VM and all the customizations you can do on Avalanche, in customizing the EM courses for you. But the only request is that you should be fairly, let's say, knowledgeable with Golang in order to take this course. Otherwise, fundamentals and multi-chain architecture and teleporter should be good to go. Now I'm gonna land up on Avalanche starter kit. So you might be thinking, okay, the guy told us all about Avalanche ecosystem and everything, but how do I actually start deploying contracts? So the first way is that obviously you change the RPC URL of your hard hat config file to C changed like testnet's RPC URL. Very simple, and you can directly deploy a contract. But like what if I want something more dedicated to use? In that case, you can use Avalanche starter kit, which is developed by Avalabs development team. So you can just go on GitHub. I'll share this link with the team so they can send it over to you. You can also try and open it right now if you have your laptop handy. It's Avalabs Avalanche starter kit. That's it. I will just quickly share it in the meet chat as well. So this is the link. Okay. Make sure that you are logged in from your GitHub profile. And when you click on code, the first thing that you usually see is local, but there is a tab called code spaces. Now there is no code space right now. Okay, I need to sign. Shit. I hate this stuff, but it's okay. I hope that I'm not sharing any kind of sensitive data. Even if I do, you don't have my security key, so we're good. Okay, so I'll go back to starter kit now, and I'll just go back to the code spaces tab. Okay, we do have one right here. But if you want to launch a new code space, you can do it just by clicking on the plus button, and you will. It will take some time, like 4 or 5 minutes. For this session, we have it handy. So just go there. Shiny space doodle, what a nice name. So setting up your code space. So in this hands-on exercise, what I'm going to do is I will set up the Avalanche local network on this cloud machine. Everything is running on the GitHub cloud, and it's free of cost for any kind of GitHub user. I think they have just some limitations on what kind of code spaces, like what is the size of code spaces that you can set up, for example, RAM, etc. But you should be like able to do it on the basic version itself. So in this hands-on exercise, I'm going to set up a simple local network of Avalanche on this cloud machine. The local network will consist of P chain, C chain, X chain, as well as a new subnet that I deploy. And I will deploy the ERC20 token on C chain, the local network C chain. And if you want, I can also deploy it on the subnet. I'll teach you for that as well. So we have some of the all the necessary files. What code spaces does is that it basically ports your repository here, and then it follows the dev container file and Docker file for all the things that it needs to install. So you can see Avalanche CLI is also present. AWS Relay is also present for WAP messaging and teleporter. Oh, shit, this Grammarly. And then Foundry is present for deploying contracts, etc. So I'll quickly open up this simple contract, ERC20, okay. And now what I will do is that Avalanche. Okay, so now you guys will be thinking, how is that guy writing all that stuff where I can find the same thing? So just go, there is in the source folder, you will find all of these examples that we have developed in-house. For example, this is a basic send receive project. This is a send round trip project. This project actually asks you to deploy ERC20 contract. I mean, it does more than that, but we'll just use it partially. So go on the instructions page and just open it quickly. And you can see that, okay, there are some of the steps that we need to follow to make this whole project work. I'm not going to tell you about what this project actually is, because that will complicate the whole stuff. If you want to learn more, we can schedule another session where I can teach you more about teleporter. But for now, we are going to create a subnet and deploy it on local network. So simply put, we're going to create an Avalanche L1 blockchain and deploy it on the local network on this GitHub cloud machine, and then we'll deploy an ERC20 contract on the C chain. That's how we're going to do. We are not going to do all the 3, 4, 5 steps. Okay. So for the step number 1, subnet configuration and deployment. So you need to first configure your subnet. I'm just following the steps here. I will not do anything different from what's written here, except if there is an error, obviously. So Avalanche subnet, create my subnet. We found a new, no, I don't want to use a new version. Okay, the configuration already exists. So I will just write force. In your case, if you're setting up the code spaces for the first time, this error will not be there. The configuration already exists. Essentially, what this means is that something called my subnet is already present. You can name it anything. Essentially, like I can name it ash subnet or maybe just code spaces, whatever. So force, and I want to use subnet EVM as the virtual machine of my subnet. What version of subnet EVM would you like to use? Obviously, latest one. Would you like to enable teleporter on your VM? Okay, let's just do it. Yes, yes, yes. Just tell yes to everything. Chain ID, you can make it like you can input everything, anything that comes to your mind, which is obviously decimal. Don't worry about like chain ID of Ethereum and all the chains which are globally available, because this thing is running only on your local machine. So you can write like anything. You can even use the chain ID of Ethereum for that matter, or Avalanche chain. In a token symbol, let's call it just ash. Uh, how would you like to set fees? Whatever default. So load SQs, yeah, works for me. Add of 1 million tokens to a new address or a evoke address. So I'm here dropping the 1 million tokens, which is going to be the native token for my subnet. Or you can call it like how ETH is to Ethereum and how AVAX is to Avalanche C chain. Very similar to Ash is to my subnet network. So in that case, we have a default account address. It's configured, I think, in the dev container.json file. We have the private key variable for that. This is the private key for the evoke address. So I'm going to airdrop 1 million tokens, 1 million ash tokens. You can check the balance later on if you want to. Would you like to add a custom precompile to modify the EVM? No, we are not getting into precompiles right now. If you want to learn more about precompiles, I would recommend you take the customizing the EVM course. If you come across like any issues or want to let's say build out a project, just hit me up with any ideas, or like I can also give you some ideas on what you can build, and you can like start on that route. So we're not going to use any custom precompile for now. Successfully created subnet configuration. Now we are going to follow the next instruction. Configuration is created. The second step is to deploy it. I'll just copy paste it. You can definitely write it, but I'll show you how I can just copy paste and deploy everything. So choose a network, local network in our case. For DevNet, you need DevNet clusters, which are AWS machines where you can deploy your subnets on the DevNet. So not publicly available from EvaCloud's team, but EvaCloud UI definitely offers you to set up your subnets on their DevNet. So if you want to try that out, feel free to do it. It's free for one subnet, by the way. So they will give you all the RPC URLs and everything, and you can just input that RPC URL to deploy your contracts. So it's deploying teleporter messenger. Let me just put it. I don't want to click on hide. Okay, yeah, it's okay. So it's deploying all the things. Here at the end, you can see that, okay, there is a code space RPC URL. This RPC URL is the, you can say, node RPC URL for my subnet blockchain. So if I ping this network with, let's say, deploying a contract, I can do it. And this is the funded address with 600. This is the default address with 1 million tokens, you can see. 1234 is the chain ID, subnet name is my subnet, network name, and currency symbol is hash. Now, this third thing, which is my third command, is that since I already launched the subnet on a local network, that means my local network is also running. If my local network is running, that means my C chain is also running. So why not I just deploy ERC20 contract now on the C chain? So I'm going to use Foundry for this. If you guys have never heard about Foundry before, please feel free to like check it out. It's a very good tool. We also use it very extensively. Most of the Ethereum developers, they use Foundry. So I'm going to like just copy paste this command. I'm not going to change anything. What it does is that I'll just quickly share with you what we are doing here. So force create, we are going to like deploy a token contract here, which is going to be an ERC20 contract on the local CRPC URL, as you can see. Let me just quickly go to that. Yeah. So the RPC URL is configured to be local C, right? Shit. Okay, yeah. Okay, it's okay. So the RPC URL is configured to be local C network. What is local C? In the foundry.toml file in the starter kit, you can find that, okay, we have already configured it as one of the variables. So local C, whenever you write local C in the foundry commands, it will automatically replace localhost ext bcc rpc, which is essentially the RPC URL for local C chain. If you want to deploy the same contract on my subnet, which is the subnet that I just created, you can just replace local C with my subnet and it will be deployed on your subnet itself. So I'm going to deploy a ERC20 token contract on my local C network with the private key PK. PK is already stored in the dev container.json file, as you saw. So it's essentially the wallet that holds Fuji AVAX, some Fuji AVAX. So it is already pre-funded, and I will not need any gas fees to be paid from my side. If you want to do such a thing on, let's say, Fuji CChain network, which is our testnet, then you need to go to the testnet faucet and get some funds. Let me know if you have any troubles getting funds from the faucet. So I'll just click that OK. So the private key where the funds need to be deducted is PK, and then this is the address of my ERC20 contract, which is source 6 ERC20 to native, which is source 6 ERC20 to native bridge slash ERC20.sol. That's it. Solidity contract, very simple. And if you want to take a look at the contract, it is very much basic. Just a simple, I think, 12-line contract, mainly for like, it takes all its dependencies from Open Zeppelin's ERC20 standard contracts and some of the things that we have configured here, obviously, but you can also do that on your end. So I'm just going to click enter after I copy paste this command, and no files changed. Okay, compilation is skipped. Deployer, this is the evoke address that we talked about, which is pre-funded wallet. This is deployed to this contract, like this is the contract address of my ERC20 contract, and this was the transaction hash. So this is how simple it is to deploy a ERC20 contract or a simple smart contract using Avalanche starter kit. Now, if you follow this guide even more, you will be able to utilize Teleporter and build a complete bridge between the subnet that I just deployed and the local chain C network. So I will definitely like ask you guys to check out some of these examples, try them out. If you find anything, let's say you want to experiment with something, definitely let us know, and we'll be like happy to get in touch with you and support you in any manner whatever you are trying to build. So and if you want to learn more, Avalanche Academy is the way to go. So I think this is all from my side today. I'll just stop sharing my screen. So hope you guys had a good understanding, like hope you guys have a good understanding of Avalanche network by now. And if there is any like hackathons where you want to like probably make us as one of the sponsors and want to build something, feel free to reach out to our team and we'll definitely look at it.
Hi, thank you, Ashutosh. So, can you please stick around for a moment and let us ask if there are any questions that our community had regarding the whole
Yeah,
PPT
sure.
that you gave them?
Sure, sure.
Yeah, thank you. Let me just ask them in our group.
Hello, am I audible?
Yeah, you are.
Okay, so Ashutosh, let me ask you some questions. So some of our folks at the club have asked us some questions on the YouTube live. I'll be repeating those questions, and if, please answer them if you'd like to. Thank you.
Okay,
So
sure.
one of our members is asking, What are some of the key challenges you faced while building decentralized applications and how did you overcome them? Would you like to answer this one?
Uh, First, like one of the first problems was that which platform to decide, like where do I actually want to deploy my application, like which blockchain is it going to be, Ethereum, Solana. So which programming languages you are already comfortable with decides is actually like the deciding factor when you're deploying your first contract, because the learning curve for Solidity, Rust, and everything else is pretty much, you can say, straight, not very much straightforward. So you definitely need to put in the effort. For me, it was like I dabbled in near protocol first, and I was like, okay, I'm not getting that part, so why don't I just build on Solana with Rust? And Rust is more suited because it's more generally used language today, even in Web 2. I was like, let's try to learn Rust. It was big tough, big tough. So I was like, okay, I'll just look at Solidity code and see what I can do. So this is like one of the first challenges. You need to decide which platform you want to build on, and then learn the programming language accordingly. There are definitely like some advancements today which help you to launch your smart contracts in whatever language you're already comfortable with. Most of them are like WASM VMs, where you can essentially write your smart contract in even C++ and JavaScript and whatever. So that is definitely like one of the pain points. Second pain point would be, mm, did like I don't think like there is any other thing that impacts one of the second. If I were to like just rate a second point, it will be like it is tough to integrate a Web3 application to a Web2 front end. So you need to like figure out how you're going to do the RPC calls and like which library to use. So today there are a lot of tools available. Like 3 years back, there were not much guides, but today there are a lot of guides, tutorials, videos online which teach you that okay, here is a front end that is built using React.js and Next.js, and how you can integrate a wallet application or some different blockchain SDK. So a lot of toolings and guides available today. Not such a big problem today, I would say.
Yeah, Ashutosh, I totally relate to your answer because I feel that anybody who's starting their journey in Web3 development should, it's like they should start with the documentation first, maybe choose a chain first and then follow along their documentation. And it's like truly a pleasure for these students that they're getting an opportunity to, attend meetings, I mean, sessions taken by people like you. Because a lot of us we even I started my development journey on my own, started dabbling along documentation and tutorials.
Yeah,
So thank you
I
for
mean,
being here.
talks help a lot. Yeah.
Yeah, so another one of our members is asking, in your opinion, what are the most critical skills and knowledge areas for someone looking to specialize?
It's okay.
I'm so sorry, I had some noise in my background. So, another question from our side is, in your opinion, what are the most critical skills and knowledge areas for someone looking to specialize in developing decentralized applications?
Mm, so when you say decentralized applications, there are different parts of it. Like, do you want to become a front end engineer who is connecting to blockchain? For example, you might be building something mostly as a front end engineer, but you want to use some blockchain available data, like some contract data, whatever. In that case, you don't need to be very well versed in Solidity or things like that, and you can just get along with whatever React.js and Next.js skills that you have currently. You can port them over. Front end skills are very much portable to blockchain applications. The problematic thing that I feel is mostly for backend people. Like today, you have a system where you are writing all the code in Java, uh, Spring Boot or whatever, and most of the companies they use a Spring Boot today for their development. And now you're asked to okay, you have to deploy a complete smart contract, and there are a lot of intricacies, especially if you are dealing in let's say financial applications. For example, you're building a DeFi application, it might go wrong. The contract might go wrong in some manner, and there might be a security vector that you overlooked. And today there's 1 million of liquidity logged on your application, and somehow some hacker gets into it and everything is lost. So there is a lot of risk for backend developers, which is why if like if you are already a good front end developer, don't try to become a smart contract developer. I mean, you can definitely get a good job just by your current front end skills. And if you want to actually become a very good backend developer, like someone who writes contract, etc., then I would recommend that try to learn, try to master the virtual machine where you're trying to build your application. For example, if you are going to be building in, let's say, EVM, Ethereum ecosystem, then make sure that you know every intricacies, all the opcodes, how they work, everything ins and outs of Ethereum virtual machine. This will help you a lot in writing super secure smart contracts. And I think for a general purpose software engineering role, if you're good with Golang or Rust, then you have lots of opportunities in blockchain ecosystem. Like there are a lot of openings who hire people who have Golang programming skills or Rust. So being good in any of these two can be also a good booster to your profile.
Thank you, Ashutosh. I hope you answered this question for the person well.
Okay.
Now, moving on to the next question. Actually, we're getting a lot of questions, so I'll just stick with the questions that make sense because a lot of them are sort of like replicas of each other. So, this one question asked by one of our members is: how do you approach security and privacy when developing decentralized applications? What best practices would you recommend? I think this is something more inclined towards Web3 security and auditing. Would you like to take
Mhm.
this up?
Yeah, sure. So I'll first answer privacy part. Security, it's something more complicated to explain. So privacy is pretty simple. Nothing is private today on a public permissionless blockchain network. Your all wallet data, everything is exposed. If I send you my wallet address, you can potentially fetch all the contracts where maybe I am holding something, all of the tokens that I hold. You can get all the information wherever I have posted on some social fi application like Lens Protocol or whatever, you can get it just by knowing that okay, Ashutosh Tripaঠি's wallet address is this. So there is nothing which is like private. If you keep your wallet address private, there are high chances that you might keep your data secure as well. Sorry, private as well. So but there are few blockchain networks which specialize in privacy. For example, if you want to keep your transactions private, or maybe you are doing some trade and you want to keep it private, there are definitely some blockchains who specialize in these things. Most of the enterprises they want to keep the data private. For example, if I was Indian government and I want to, let's say, bring Aadhaar data of all the Indians on chain, then I'm not going to do it on Ethereum. I'm not going to do it on Avalanche chain. I'm not going to do it on Polygon, PS, or Solana. Never. What I'm going to do is I'm going to create my own blockchain network. It can be using Avalanche L1 tech stack. It can be using anything. And I'm going to set a simple flag, which will enable privacy by default on my whole blockchain. So any data that is processed by the validators in my network, it will not get out. So nobody outside of my validator network can see the data of transactions or like users. So that is like a kind of very brief answer to how you can handle privacy in blockchains. Security is something which is more complicated. So if you're running a very small set of validator network, then security is of utmost responsibility, because if any of them goes down, it is if any of them gets compromised, it's like your whole network is gone. But in the other hand, let's say you're running a very big decentralized network, let's say Ethereum today or Avalanche today, which has like 1,000, 2,000, 100,000 of validators. In that case, security is provided by the ecosystem participants itself. So the people who are validating the network, they make sure that okay, all the transactions they are secure. All the blockchain transactions that are getting added to the block that are being finalized by the blockchain network, they are secure by default. Now, if you're talking about contract security, that is a completely different thing, and which is why we do have so many auditing companies today, smart contract auditors. They do charge a lot of money. I mean, they are in very high demand. Teams like Open Zeppelin, their whole specialization is in like smart contract security. So what their job is that they take your smart contract and they will come back to you with okay, these are the potential security vectors and these are the potential optimization that we can suggest you to make your blockchain application more secure. So if you decide to, let's say, build a company from and some part of your company involves creating a smart contract, always make sure that you get it audited by multiple firms. This is the only way to ensure security on your protocol. Otherwise, there are very high chances that it will get hacked in the future.
Okay. Thank you for that answer. I think Web3 security is a very critical part of any Web3 application, and that that fact becomes even more. It makes more sense after looking at all these breaches happening right now in the Web3 ecosystem. It's truly sad. Now moving on to the next question. Okay, this question relates more to your journey as a person in the Web3 ecosystem. So, okay, just a second. I think I lost. Yeah, the question is, can you share your journey from working at Polygon Labs and Web3 to your current role at Labs? What motivated you to transition between these roles?
So uh, I will just tell you about how I got my first job, and it's a very funny story. So I was writing technical answers on Quora. Like even if you search today, you can find my profile and you will see some of the answers. I got like 1.5 million or 2 million views on my answers. I was just explaining Facebook's architecture and what programming languages they use and how they utilize what is the algorithm they are using. Things like these. I was just breaking down them, and I was like, okay, this is not a full time job. Obviously, I was just doing it for fun that time. I was in 10th class. Now, fast forward to when I reached college, I created another blog. It was essentially a technical blog where I will sort out, let's say, some random technical questions that you have. For example, I'm getting the BSOD error on my Windows machine. How do I resolve it? Or I'm dual booting my laptop with Linux and Windows. How do I do it? I'm stuck here. What is the solution? So I'll write blogs on that or anything that is new happening in the technical ecosystem. I couldn't continue it for much long because obviously, like you guys, I also had pressure from my parents that okay, you need to take up a job. Simple as that. I won't like try to sugarcoat it. So by final year, I was preparing for SD roles, all the like crazy stuff that you see, DSA and whatnot, creating projects and everything. And I got a job. Like it was not a very big job, simple software engineering intern at Incedo, which essentially would have been a full-time role as well after the internship, which is what they offered. Not a like very dreamy job, but I was like, okay, why don't I give it a try for the next 5 months? And at the same time, I will choose that probably I can grind DSA and get a job at Amazon or maybe do something else. So it's just tinkering around different ideas on what I can do. And in January of 2022, I started my blockchain journey. So I got to know about that, okay, there are some remote jobs hiring, you have a lot of freedom and all that stuff. So I contacted one of my friends who was working at a blockchain startup, and he told me that, okay, why don't you like, you already have some skills, like you can develop good front ends, and you also are good at technical writing, so why don't you like apply for these roles? I was like, what is technical writing? And he explained that, okay bro, what are all those medium articles and all the blog articles that you've been writing and Quora answers, they're essentially like you're essentially writing technical content. So that is technical writing, which is what documentation and all the engineers also do. So I was like, okay, this is something that I already have. So I built my first project during the Encode challenge. I started from a hackathon itself. I like didn't learn how to write smart contract. I mean, writing a smart contract was not the first thing that I did. The first thing I did was apply to a hackathon, and we'll see what we can build. So they had this challenge statement that okay, you have to build an NFT marketplace. I chose Near Protocol because I already got a you can say I got in touch with one of the developers, and he guided me very well on how I can build it. I got in touch with him on Twitter. Twitter is a very good place if you are into Web3. So if you want to actually build a career in Web3, make sure that you're definitely active on Twitter and share your learnings, whatever you're building along the way. So I got in touch with him, and he helped me like sort a lot of issues. And me with my partner, we won the Encode challenge by building an NFT marketplace on Near Protocol. That was the end of it. But at the same time, I was also trying like my luck at some of the other college placement companies. Like Oracle came, they rejected me. All of these things were happening, but then I reached out to Richa Joshi from Push Protocol via email. I told her like they were hiring for a technical writer, and I told her that okay, I have this many skill sets, and I would like to work as a technical writer and possibly a developer advocate as well for your company. So I got in. I think there were two interview rounds, very quick ones. Hiring in Web3 is pretty much, I think, more focused on what you have already as your historical skills or whatever. Like you should have a proof of work instead of that. Okay, you're coming and to the interview room and grinding DSA just one day before, and then you say that okay, ask me any question. That does not work in this industry. I'm not sure about like software engineering roles, But for roles like DevRel or technical writing, they more so look at your proof of work. So I already had these things from the past, like Quora, my Quora profile page, everything, and my blog that I had. Like I just set up the blog one day before the interview so that I can showcase that, okay, I have this thing from the past. So she liked them, and she offered me a role. That was my first role as a technical writer. I wrote the docs for push protocol today, which is push protocol today, the developer docs. And soon after, like after 5 months, I was let go from the company, and then I got another offer. So you can also call it lucky, because at the same time, a lot of layoffs were happening in crypto. You might remember the time. I think you guys are pretty new, but if you go back to the time of June, July 2022, you will see that, okay, Coinbase was laying off a lot of employees, everybody, all because things were going into bear market. So I was also laid off, and I was just looking for opportunities when I sent a connection request to Chetan Bageri from Polygon Labs. And I just sent the connection request. I didn't ask him for a job, whatever. I was like, I was planning to ask definitely that, okay, once he accepts the invitation, I will definitely ping him to for some job role at Polygon. So as soon as I sent him the request, he accepted, and he reached out himself that, okay, we do have a role for a senior technical writer at Polygon Labs. We think you will be a good fit. So why don't you get on a call with us? It was like, you can say, a dream come true at that time, because Polygon was one of the first companies that I wanted to work at, uh, because mostly because it's an Indian company. That is the first reason. And I'm a big fan of JD Khan and how he built the company. Definitely, he left the company today, and a lot of things have happened at Polygon since I left as well. But at that time, I was a big fan. So I joined the company after like 2 or 3 rounds of interview, and mostly I worked on the documentation for Polygon ZK and Polygon Miden, also sometimes with Polygon POS as well. So Wiki was this product mainly for docs and everything, but after 1 year of time, I realized that, okay, career is a bit stagnant. Like I can become just a lead technical writer, but why don't I look into something other, which is also relevant to my industry, as well as also relevant to whatever experience that I currently have. So developer relations was something like which has already 30-40% of technical writing. Like you have to write guides, you have to write tutorials, explain things to people, but at the same time, you also need to have some development skills so that you can build stuff. So I started applying at different companies. I reached out to the hiring manager for this role at Ava Labs. Thankfully, he replied. I got lucky that time as well. And this is how I'm currently working today at Ava Labs. It's almost 1 year now. So, yeah.
That's truly an amazing experience that you just shared with us. I hope your journey inspires our students, and it's like very important for students right now who are just getting into the space to understand how important it is to network and play around with things on your own. Mostly, a lot of times, even I mean, right now, most of our club members are made up of third years and fourth years, and these guys are preparing for placements. Because after all, in the end, we all, the end goal is to get placed in a good company, right? So most of the students here are like really, they are a bit hesitant into going down the Web3 path, and they would rather, feel more safe if they go down the traditional Web2 path. I mean, just preparing DSA day in and day out, and then sitting for placements interviews. But I think the Web3 way is a little bit different. You have to, reach out to people on your own. So networking is important. You need to learn things on your own, because we don't have any traditional courses in our colleges. Like even if we do have courses, they're not like at par with what the industry standards are right now. So I hope you're enjoying, and thank you for all of your answers, Ashutosh. It was great to have you here. We have a lot more questions with us, but unfortunately, we have to stick with the time limit. That's why I hope these I mean, in a way, answered a lot of questions that were asked here. And thank you so much, Ashutosh. Do you wanna end with some like? Do you wanna end with some
I
words?
think one of the like major takeaways from my whole journey you can learn from here is that if you want to actually build in Web3, or if you want to like get in Web3, even from job perspective, or if you want to like actually build a company, this is the best place to be. It is like essentially being in the Web 2.0 era during 2003, 2004 time when Google and Facebook, everything was building up. So This is like going to be the technology of the future. And if you want to become a developer, the best point to start your journey is a hackathon. If you want to become, let's say, technical writer or something more on the lines of, let's say, developer stuff like that, or want to manage community, then the best thing would be to take your current skill set and just to start applying and try talk to different protocols. There is definitely a place for you. And don't think that okay, you lack skills or whatever, because most of the times it's your current skills which are you're gonna use at your new company. So don't like feel afraid of it. And that's all. Just participate in hackathons, build stuff. Make sure that you showcase it on Twitter or your personal website or whatever, LinkedIn, and build connections. That's it. That's all from my side.
Yeah. Thank you so much, Ashutosh. I think we'll have to end here. Thank you for giving your time, and it was a pleasure to have you with us. And we hope we stay connected in the future as well, because the entire purpose of making this club, we started this club like a year ago, and the main purpose why we started this was because we wanted to give a platform to our students, so that where they could interact with people like you, and meet people from the industry and know more about what's going in the Web3 space. Because
Absolutely.
all yeah, these things are not approachable for students like who are enrolled in traditional courses over here. So we are sort of a window to our students into the Web3 ecosystem. So thank you so much. And we're going to have a hackathon soon in some months' time, and sure we'll contact you regarding that. I hope you stick around with us for some
Definitely.
more time. Yeah. And thank you so much, Ashutosh.
All right. Thank you, everyone. Bye bye.
Bye.
Bye.